there, welcome to new video of software engineering. In this video, we are going to see test strategies of OOPS software, validation testing, system testing, and art of debugging. This is part of Unit 5, which we are going to discuss today. Correct? Let me start with this one. Testing strategy of object-oriented software. If you are using object-oriented software, we are going to have class, other things, properties in that one. That's how we are going to discuss it. With object-oriented software, we can no longer test single operation in isolation because we cannot do a single operation because each and everything are connected to each other. Traditional top-down or bottom-up integration testing has a little meaning of it. Why everything is connected in the class and they have got functions in it. That is called, if you have a class like this, there is a class name, and then there are attributes, then there are functions. So these are all related to either. We are not bothered about this one, but this and this there are. So we cannot able to do it with top down or bottom up approach. Everything is related to it. Class testing is object oriented software is equivalent to unit testing. For conveniential software is testing on a single site. If you have a unit testing process will go up. What do you mean by unit testing? Testing a single class at a given time. That is what it is. Focus on operation of encapsulation by the class and its state behavior. Focus of the class and how it's going to behave for certain type of input and certain type of output. We can use drivers. If you use drivers, you are going from bottom up approach. If you have gone through my previous videos, you have seen it. The drivers are used in bottom up. The test operators at the lowest level and the testing whole group of a class. So we test a small part, then we combine all together and test it. So we use drivers. The replacement use interfaces to test the system functionalities, then conduct the implementation actual interfaces. We test this one, then we check what are the interfaces it uses, what are the functions it is going to use, and we also use stub. Sub is something like that we use for top down approach. Situation which is collaboration between classes. If the classes are collaborating with each other and one or more collaborating classes not yet fully implemented, and what happen is that there are systems which are working two classes working together. In some part, a few part is not been developed properly. So what you can use simulation part of that. That is called sub or replacement. Some model who haven't finished, for that reason you can use sub, and drivers also use. But basically in this one we use unit part testing. The next part, what are the strategies we are going to do? Class testing equivalent to unit testing, as I have already told you. Operation within the class are tested. Inside the class is tested. The state behavior is also examined. Different situation, how it's going to behave, we are going to do. There are three integration parts. Different type of strategies are used. Thread-based testing. Integrate the set of classes required to respond at one input. Different classes respond to same input. Then we call it as thread-based testing. User-based testing. Integrate the set of class that require response to one use case. Means integrate this one classes so that they respond to one use case. All the operation like your input page or something like that. Cluster testing. Integrate the set of classes that demonstrate one collaboration. Different classes work together for specific tasks. That's what I told you of. That is your input page. Different classes work together for this one. We call this one as cluster. Use based independent class. If this means use based testing, integrate the set of classes required respond to. There are independent classes that respond to one case, then we use this one. And thread based, integrate a set of class that required to respond one input. So these are the tests. Basically, classes are used for unit testing, and there are three types of testing in that one. That is thread based testing, use based testing, and cluster based testing. Validation testing. What do you mean by validation testing? Validation followed integrated testing. It give you the required output or not. Correct? We have already seen in our previous classes, the previous videos. Distinguish between the conventional and object oriented disappears. So focus on user visibility action, focus on visibility action, user recognition output. We focus on what is the user input and what are the user output from the system. User interface, demonstrate the required things. What is the user input? What, because we are checking for the output, so it has to give you the required output what the user want. So if you are getting required output, all the function required are satisfied, all the behavior characteristics are achieved, the performance required are attached, documentation are correct, usability of other requirement, that is transportability, compatibility are achieved. After each validate test and performance characteristic like acceptance testings and other things are being defined. We are going to see all those in coming slides. Example, this is the example which I have taken it for validation. Imagine you developing a new mobile app for online shopping. How the validation testing? Are you integrated all part of application like login, product and everything? Test that uses all performance like search, application, ad, chart, checking out. Goal, functional required, ensure all successfully search what user want to purchase, ensure app record correctly user action like showing confirmation message and person. Performance, ensure that app loaded quickly all transaction, ensure all user guide or help are there, ensure all user navigate through all this. Post validation, perform each test, check the app work specifically. If feature does not correct, we note down and fix it. Confirmation, confirm configuration review, you review all component in the app to ensure that it properly integrated with the document. This is the part which we have done it. So configuration review or audit, ensure all elements of the software are related or checked. This is validation testing. A validation testing is that the end part of it which we have already done it and it is giving the required output. Now comes your alpha beta test. The simple way I can tell you, in alpha the developer is present and it will able to fix the error, whereas in beta the developer is not present and the user or the end user will record the testing and send it to that one, whereas in alpha environment is there. So example here, conduct the developer side by end user. Alpha testing, it conducted by software use as natural setting with developer watching intensely. Testing is controlled environment. Conduct at the end user. Develop generally not present. It serve like application software is software in an environment that cannot be controlled by the developer. Here developer control the environment, it cannot be controlled. The end user record all the problem and then encounter the report to the developer at regular interval. This is called alpha beta testing. Then system testing. What do you mean by system testing? A recovery testing. Type of testing, recovery. Test the recover from system fault. From where it has fault, from there we have to recover it. Focuses software fail, variety of ways, verifies that record and properly inform. Test other part like checkpointing mechanism, data recovery and restart. Security testing, verify the protection mechanism built for the system. Stress test, execute the system in manage is demand the resources, abnormal quantity, extreme condition, focus on frequency and volume. Performance testing, a runtime, how it's going to perform. Couple of things which we are going to see. Is type of system is nothing but these are the things, correct, which we have to do it. Then we have got art of debugging. So this is the basic diagram of this one. We test, we result, then we debug. Identify the cause, correctness, regulation. Other one, suspect cause, again additional test, we go for testing. If occur like this we go, otherwise identify the cause. There are two ways we can able to go there. This is the basic diagram of debugging. So what is debugging process? Debugging occur at consequence of natural testing, successfully testing. It's still very much art rather than science. It's an art of taking out error from the software. Good debugging ability may be intent human trait, means it can able to have human ability and it can able to take all those things. The debugging process begin with the execution of test cases. The debugging process start with the execution of test cases. Results are assessed and the difference between the expected and output performance are acted. What is your input? What is the output? If any differences, then we need to debug and find out. Debugging is a process of efforts, is time to require diagnose the system to cause, time required to correct that, conduct regressive testing and find out all those things. Debugging is a process, time required to diagnose the system and determine the cause, and time required to correct it in this one. Why debugging is difficult? The system and cause of may be geographical remote. Somewhere down the line, it may have it. The system may disappear temporarily when other occurs can occur. So whatever the error is there, it can be disappear and other errors will occur. System may actually be caused by non-errors like ground of inaccuracy. System may be caused by human errors, a timing problem. All this will come up. Objective of debugging. The main goal of debugging is to identify and correct the root cause of a software. Correct? Find the correct cause of the error. So, realizing what the object debugging involves. Systematic evaluation. Carefully analyze the software. Experience, guesswork, luck sometimes. Correct? So, the role of debugging. Debugging methods are tools aid to protect but not to substitute the careful evaluation. Tools or methods are to helpful but not sufficient alone. There are three types way we can able to do it. First one is brute force, where we can just whatever the program is there, we take out the printout, we check line by line to find the error. Use print statement debugging rather than program state information. Detail examination is there. Then backtracking, start from the error point from where and we start to work. If this is an error, we go back from where it is there. Systematic approach to point where it went wrong to identify the source of the error. Then main cause elimination strategies, hypothesis. Use if this is right, what will be that? Like mathematical equation, product potential costs. Systematically eliminate each hypothesis through based on testing. Based on scientific approach, we can able to go for hypothesis testing. So, in summary, debugging is a critical cost of software development, involve identifying and fixing error. It uses brute force, backtracking, and cost elimination. Challenges include remote systems, temporary disappearance, non-error of cost. I hope I have already cleared. Thank you very much for this slide, for this video.